Perfect. Okay, so we'll start. My name is Dan Pan, a founder for Haddee Education. And here we have Mr. Mauro. And Mr. Mauro, would you like to introduce yourself?
Yeah, thanks, Dan. So my name is Tony Mauro. Nice to meet you all virtually on Zoom, and thank you very much for coming. What we're going to talk about is the summer camp that we have at Berkeley in the July timeframe in this year, 2025. So my background is I met Dan at Qualcomm. So I was in San Diego from 1990, early 90s through just about last October. So I recently moved to the Bay Area, like Dan moved to the Bay Area. I'm in the Bay Area now too. I worked at Qualcomm as a design engineer in hardware and systems and digital signal processing. And this is where I met Dan. She was my program manager for many programs over the years. And so I worked in that industry, and then I started teaching at a local high school in Carmel Valley called Canyon Crest Academy. It's a public high school. And I started teaching there part-time from about 2008. And then I finally left Qualcomm in 2015 and worked at Canyon Crest Academy until just this past June. About 3 years ago, I started working at UCSD. So I teach machine learning and digital circuit design at UCSD. I do that remotely. I recently moved in October to Marin County, which is just north of San Francisco in the Bay Area. So I'm again a neighbor of Dan's up here in the Bay Area. And I look forward to hopefully working with some of your kids at this summer camp. So what we're going to talk about today is what we're planning on providing students with these experiences in both machine learning and circuit design. I'll talk a little bit about why I think it's important that we cover both, but we will get into that in just a little bit. So so thank you again, Dan, for the intro, and welcome everybody to the webinar. And so let me kind of go to the next slide. What we're planning on doing is to provide an introduction to both software and hardware foundational components in machine learning algorithms that are essential to the basic components of AI and the kind of the craze that's going on right now with the generative pre-trained transformers, or the GPTs, right? So everybody knows about ChatGPT or the Anthropic Claude chatbot, or the Gemini one, or the one that's with the Meta AI or XAI. There's many of them, or DeepSeek, right? I mean, the newest one has come in. Many of these have kind of come to the forefront of everybody's mind in the last couple of years, right? ChatGPT first, and then the rest of them came in. And so this is really a foundational camp that supports a stepping stone to get to the point where you understand what is happening when you are working with large language models and transformers, pre-trained transformers. There's a lot behind that. It's not as simple as just calling an API available in a machine learning library. I think a lot of students that I've been exposed to, both at the university and the high school level, that work on research projects and science fair projects and different camps and internships, they work on an application and they say, okay, well, I'm going to implement a machine learning algorithm on whatever it is. It's maybe it's a life science application or a business application, and they don't really understand what's going on underneath the API that they call, right? The application programmer interface that they call. So they call a software, they know the software, they claim to know the software, and they call the function to implement, say, a neural network, and it does some classification on their problem that they're trying to solve. But they really don't understand what's going on underneath it. So when I was teaching at the high school level, actually, I decided to create courses in both hardware and software that produce this introductory foundational courses that will support the understanding of these more advanced topics. When I started teaching that, it was made known to UCSD, and UCSD reached out to me then and wanted me to start teaching these topics at their university. So these the content that that Dan and I will be supplying at the summer camp is tested and has been through many iterations of students that have gone through these programs. I believe that there is a fundamental connection between both the hardware and the software in these in being able to be competent in these areas. I say that because with ChatGPT and Claude and Gemini and the others, there is you hear this in the press, and you hear the fear about software programmers being replaced by the AI agents, right? You hear a lot about that, and all of our jobs are going to be taken, right, by the bots. I'm not convinced on any of that, but I am more so concerned that fundamental coding is going to be replaced. I think that, I myself and many students that I've been associated with know that they can prompt an AI engine and get responses back of code that's implemented, with it's well coded, good performance, and minimal bugs. And if they have bugs, then the bot can actually fix the bugs. So that's all. I think that's all coming. It's not quite there yet, but I think that in the future we're going to find that many software designers are actually using the chatbots to fundamentally code what we had armies of programmers coding in the past. So I think it's important that we understand both hardware and software. You need to understand what the algorithms are. You need to understand what is happening in the algorithm, and you need to understand the underlying hardware architecture so that you can take advantage of efficiencies that have been designed in parallel processing, like in neural processing units or GPUs that, say, companies like NVIDIA have made so much of an impact on the processing of large language models. So I think it's important that next generation engineers will understand both, because I think we're going to end up with hybrids of a computer slash software, computer science slash computer hardware engineer that has to understand both in order to be productive in industry. And I think you're gonna find that. So your students, I think, are going to want to understand them both. So what we're trying to do in this summer camp is to present introductory material so that they understand both areas. What we're going to do, and I'll show you what kind of the schedule is for our camp. We're going to cover two areas. One will be we'll cover half of the time will be in the software region, and half of the time will be in the hardware region. When we cover the software region, I have a little diagram here that's shown in the slide that sort of depicts what my view is of all of the kind of the components that represent what originally was data science, which then incorporates artificial intelligence, AI. Within that AI bubble, you see is the machine learning engines that run the algorithms that form the AI, chatbots and the other applications. And then within machine learning, there is everybody knows about a neural net. Everybody, or at least has heard about a neural network, right? That's what's called deep learning. Within deep learning is where you see that the traditional deep learning neural networks were formed from the very base, back in the 1950s when the basic model of a biological neuron was formed, and those neurons were grouped together to form layers of neurons, and those formed what's called a multi-layer perceptron model. And that's what ultimately became what's called a deep neural network. From there are many variations. The convolutional neural network handles images better. A generative adversarial network is if you're trying to do things like produce, videos. That's where when you hear about deep fakes, those are based on GANs, right? The GANs, the generative adversarial networks. And then from within the neural network realm is where the transformers came, because what you needed to do when you're trying to absorb speech or text is you have to understand context. So you have to understand some temporal capability of the document that you're trying to absorb. And so that's what large language models do, right? They pull in a lot of data from the internet, right? Or just documents in general. And what they need to do is understand the context. So knowing, okay, what's the order of the words and what is the context between, a word that's a descriptive word like an adjective or an adverb, and the actual, the actual decomposition of the sentence itself. To understand that, you need things like embeddings, and you need to have different types of architectures that have memory associated with them. Well, a deep neural network doesn't have that. So they have different newer algorithms, which are called recurrent neural networks, that then form things like the long short-term memory networks that ultimately become what are called transformers. And those transformers then form the base of what is called a GPT, right? A generative pre-trained transformer. Those are the things that form the bots that we know today. And they work primarily with textual documents, but more and more they are becoming what is called multimodal. And multimodal are things like, okay, well, not only it's sort of simulating what the human can do in terms of their senses, right? They have vision, they have hearing, they can read, right? They can speak. So all of these senses that we have are starting to be pulled into these models that form what's called a multimodal large language model. And as these become more evolved, they're going to become more human-like, and more. It's where robotics will come in, and there's going to be this very large evolution and large ramp to be able to utilize these. They're not quite there yet, and if you really push the bots to generate code and to generate your documents or your whatever it is that you're looking for it to help you with in terms of a personal assistant, they have some flaws associated with them, but they're getting better as time goes on. So what we're trying to do is we're trying to say, okay, well, this is such a large area. How do we get to a point where we really understand what's going on, as opposed to just saying, let me prompt an engine, right, and get some code back and not know anything what's going on underneath it. That's not an engineer, right? You're not an engineer if you do that. What you have to do, in my opinion, is that you have to understand a little bit about what's going on underneath it. You don't have to understand everything, with the details of every single code structure, but you should understand generally what's happening with the algorithms and know how to work with them. And so that what we do is we form sort of a base with the Python programming language. You have to know that. And that's one of the prerequisites of this camp, is that you know some fundamentals of Python. We're going to go really quickly and do a deep dive, crash course in Python just to make sure everybody is up to speed. In order to get into this camp, you have to pass some baseline Python set of questions. Pretty easy, pretty straightforward. If you can do those, you should be fine in the class. But if you can't, you're going to struggle. And it's because we're going to move pretty fast. There's some basic statistics, linear algebra, and calculus that you need to know about in order to be able to get through the algorithms part of this class. If you don't know those, you may have some trouble with that, but we'll go through them just quickly. And so once we get through there, we will talk about clustering and classification, dimension reduction, and then we'll get into neural networks. So that's the parts that we will cover in the computer science side of this camp. Basically starts with a foundations part, crash course in Python and the libraries that are needed, NumPy, Pandas, and Matplotlib. We'll talk about machine learning algorithms, classification, regression, classification, clustering, dimension reduction, and then we'll go into deep neural networks. So we'll talk about what does it mean to be a basic biological neuron model, and how do you build that up into a larger network. We will also then look at the foundations of what does it mean to generate hardware that can support the software that the algorithms will run on. And again, I have several students that I worked with at CCA, including Dan's sons, both of her sons, that have gone on to do really very interesting and impressive things. In the end, you have to really have a good idea of what it is that you're working with if you're a software engineer, and how to take advantage of your hardware. I have several students also that work at NVIDIA, and that company is so successful because not only do they develop the hardware, but they have the software stack on top of it. So really, to understand both is important. With that, we will cover basic combinational and sequential logic and their applications. We'll talk about hardware description languages. This is how all hardware is developed these days. It looks just like software. You have to understand object-oriented programming. You have to understand what a module is and how you would instantiate it, and create, general structures. And then we'll apply that to what we would have from as a base in machine learning. For example, a neural processing accelerator that would be is what would be used today from companies such as Broadcom that do a lot of customization of neural processing engines for these companies as they try to build up their own data centers. So here is I'll go through this really quickly because, instead of going through every of these points, I'll go through this quickly in terms of what we're going to cover day by day. We're going to split it up into AM and PM. This will hopefully keep the kids interested and busy. They'll be very busy, both during the day and in the evening. We will have exercises that they'll work on in the evening, but in general, what we're going to do is a real crash course in Python fundamentals. We to understanding that people coming in should have some background in Python. They don't have to be experts, but they have to have some background in it. We'll cover the development environment that we're going to be working with. It'll be a Jupyter Notebook based environment. We'll use Google Colab. That's very simple and cloud based. You don't have to come in with an installed code base or a super fast computer. As long as you have internet access, you'll be able to utilize the tensor processing units that are exposed to us through Google Colab in their free version. So it's pretty powerful in itself. So we'll cover some, very quickly go through some very fundamental things with Python data structures. You need to understand what OOP is, object-oriented programming, and some of the advanced functions. And so we'll go through some assignments and projects associated with that. And then in the afternoon session, we will switch gears and go into the hardware side of things. So we will talk about what digital logic is, combinational logic, sequential logic, so Boolean. We will use a tool called Logisim. It's what they actually use in their courses at Berkeley. Many of my students are pretty familiar with this tool called Logisim. We'll look at what a Boolean equation is. How do you optimize it using Karnaugh maps? How you build basic arithmetic logic units through the base functions that you would use with a simple calculator type function. We'll do that all in the first day. So lots to cover in the first day. Second day, we're going to look at the machine learning library. So we're going to jump right in. First day, you got to be good in Python. Second day, we're jumping into machine learning libraries. So we're going to start to learn vectorization, how to handle some data sets pretty efficiently with pandas, and then how to visualize our outputs with matplotlib. We will do that in the morning, and then in the afternoon, we will go into sequential logic and do projects. We actually do hands-on projects where we're going to build some hardware in the classroom, and I'll provide hardware for the folks to be able to build basic circuits. In the third day, then we will go through some projects with exploratory data analysis. So this would be like if you're a data scientist, how do you scrub data? How do you evaluate the variables, and what kind of trends can you extract from them? So we will go through some real world examples on that, and then we will look at the math that's required for machine learning. Now they don't have to have full year, in exposure to statistics, linear algebra, and calculus. Many students have this, and they have exposure to it in high school through, like AP classes and things like that. But I will teach them everything they need to know, and as far as what they need to know with statistics, in terms of, being able to characterize a distribution and how to standardize data. With linear algebra, what is vectors? What are matrices? How do we work with those? That's very important when we're working with multi-dimensional data in terms of a data set. Again, a real world application where we have real data and we're trying to determine trends from it and do some kind of research and analytics on that data. And then calculus, we need to know basically what the two main functions in calculus, the derivative and the integral. You need to know what a derivative is. I will show folks who don't know what a derivative is. I'll show you how to calculate it. We need to be able to calculate it because when we study neural networks, we need to be able to formulate a what's called a cost minimization function when we are training the network. So again, I'm not going to just tell the students, call this function, it will do everything you need it to do, and spit out the answer. That's not good enough for me. They need to understand what's happening behind it. And so they will get a good feel for how backpropagation works in a neural network, how you train a neural network to adapt the weights and the biases in all of the nodes and all of the layers in the neural network. And so they'll have lots of exposure to that. This is very important, and one which, when I've taught this in my classes, students have come back to me when they've, from high school, have gone to college and have asked for their old assignments that they did in my classes, because they said, this is what exactly I'm doing in my college class, right? In my college in my college class on data science or in machine learning. So it's very useful and very applicable to what they will see in the future. Sequential logic then in the evening on what we're doing with how do you generate a clock? What's the fundamental component of a sequential circuit is a clock. What is a counter? How do you create divide counters, things like that. And then on day 4, we'll talk about the most famous cost minimization function called gradient descent. We will look at applications of that, specifically as it relates to regression, linear regression, multiple linear regression, where you have multiple independent variables. We'll look at that. And then we'll also cover in the evening with the hardware side, we'll cover state machines. So they'll build and implement state machine sequence detectors. We will be using what are called FPGA, field programmable gate arrays. That's what that stands for. Those are essentially emulation hardware platforms that are typically used by hardware engineers to prototype different hardware algorithms or hardware circuits before they actually go into a custom chip, into a custom ASIC. An FPGA is a chip itself, but it's programmable. So you can configure the inside of it to do different functions. We use these extensively, and Dan knows about this. We use these extensively at Qualcomm to prototype our chips before we would actually what they call tape it out. Before you would actually manufacture the chip, you have to prove that it's going to work, and so you do that with FPGAs. And so we'll use an FPGA emulator board to run and implement some of these algorithms that we will design in hardware. Then in week 5, everybody will have their own kind of pace that they work at. We're going to have different levels of students coming in, and so we'll do a catch up of all of the projects that we've done to this point. Again, it's moving pretty fast in this first week. Kids will be very busy. So we give them a day to catch up, and then we give them an assessment. So they have to get through, some hurdles to get through this. Nobody's gonna, kind of skate through it. So you have to do an assessment, and then demonstrations of a project that I will assign, and they have to complete. Okay, and so they'll have to show that to me. And then when we start the second week, we will get into the kind of core machine learning algorithms in the mornings, linear regression, and then we'll look at classifiers. So I'll do the machine learning. In day 6, linear regression, classifiers, k nearest neighbors. That's a supervised classifier, and then we'll look at a unsupervised clustering algorithm called k-means. These are both very common and famous algorithms. If you know these are ones that maybe an interview, you may see that on an interview. If someone's interviewing you for an internship, they may ask you, if you say machine learning, they may ask you, what does K and N mean, right? How does that algorithm work? We're going to learn how that works. If they ask you how k-means works, it's not good enough. And this is how, again, Dan knows I was on the engineering side when I would interview entry-level engineers and interns. They may say, oh, I know K and N and I know k-means. And I would say, well, how does that work? Explain to me how it works. Get on the whiteboard and explain this out. Dan knows this very well. We would get the candidates up, and they'd have to on a whiteboard kind of explain to us how this stuff would work. And so with k-means, it's not enough to just say I would call an API, right? I call a function from some library. That's not good enough. You would need to know what's going on with the algorithm itself. How does it work? And so we'll learn that. And then after that 7th day, then we'll get into neural networks. So we'll get into what is the mathematical model behind it, behind a biological neuron. What makes up a synapse, for example? What's a dendrite? How is it modeled in software and hardware? What's an axon? How do those parts relate to the actual implementation that you would see in a deep neural network that is implemented in software today? So we'll get into that, and we'll see how those models work, and we'll talk about how you train a neural network and how that model basically works. In the afternoons, then we will be looking at the hardware side of it. So in that second week, we're going to be looking at hardware description languages. If you talk to anyone who is a hardware engineer, everything is done using a coding language called HDL. That's the kind of the general hardware description language term, but there's several different hardware description languages. The two most prominent are one's called Verilog and the other one's called VHDL. Verilog is the most common. That's the one that's used most in industry. VHDL is usually used in the academia and in Europe, but in the States and in industry, we use Verilog. So Verilog again is very coding centric. It looks like code. It actually is code. You're not connecting wires anymore. Now you're connecting modules via software. And so I introduced that. That's how it's done in industry these days. It's not done by connecting wires on a schematic. You do it with coding in Verilog or VHDL. And so we'll do that. We'll introduce what a module is, what a test bench is, and we'll look at how you would implement both combinational and sequential logic that we studied in the first week. How you would do that in HDL. And again, you don't need to know anything about hardware in this camp. You need to know a little bit about Python software, but you don't need to know anything about hardware. I'll teach you everything you need to know there, because normally students don't have that kind of exposure. Once we get into the kind of the later part of the second week, then we're going to do a capstone project where what we're going to do is implement a simple neural network, which is essentially the kind of the basis of a neural processing unit, an NPU, and we'll do that implementation in Verilog. And in concert, then we will also be working with deep neural networks when we're doing the software side of it. So again, we're trying to synchronize both the hardware and the software side that you're learning kind of the similar type concepts in both. And then the last 2 days of it, we are continuing on neural networks. So both in the hardware and the software side, we had our last day to do our second week assessment, and then we're doing projects. So like I said, there is a lot that we are covering in this camp. That your students will be very busy. If they're not, then they're not in the camp for the right reason. But they will, if they want to learn some of these kind of concepts, and they're not, if you know all this stuff in fundamentals, if you already know everything about machine learning, and you know all these algorithms already, and you've implemented them all from scratch, and you know how they work, then maybe the camp's not for you. But if you are interested in understanding under the kind of, we call it under the hood, right? If you want to understand what's going on inside the algorithms, how it really, how it honestly works, so that you can explain it to somebody like an interviewer. Like, when I interviewed at Qualcomm, this is the kind of things I would ask. If you want to be able to explain that, and to be able to understand the hardware behind it, then I think this camp will be very interesting to you. What we look for in the prerequisites are that the students be familiar with basic Python programming. Again, they don't need to know hardware. They need to know what a basic logic function is. Do you know what an AND function is, an OR and a NOT function? That's all you really need to know. And again, if you don't know that, I can teach that to you in 5 minutes. That's pretty straightforward. You should have at least a good second year algebra class underneath your belt, right? You don't need to have calculus. You don't need to have AP stats or anything like that. We know in these second year algebra classes, the basics of statistics already. You know how to interpret some data. You do things like line fits, right? And calculating a simple linear regression is just essentially a line. You know what a distribution is. You know what a mean and a standard deviation is. We'll go through that as a review of all of those concepts. But most students at this point have already seen this. Linear algebra, vector, and matrix math. Many students already know what a vector is. Some students will know what a dot product is. Many students will know how matrix multiplies work, whether it's a element by element or Hadamard matrix multiply or a dot product, standard matrix multiply. They'll know this already, but we'll go through it. And then I will also teach them, if they haven't already seen it, what a derivative is and how to calculate a basic derivative through the power and the chain rule. We'll go through that. The students must have a personal computer with the following software installed. You need to have internet access. You need to have a Chrome browser. This is how we're going to do all of the machine learning, which will be done with Google Colab, which essentially is a Jupyter notebook. That's how it's done in the universities at this point. And so we will follow that. Plus, it also makes sure that we all have the same libraries, and you don't have to have a very advanced computer to be able to do this. All you need is internet access, and we'll utilize the cloud-based processing units that Google has in their free thing, so you don't have to pay for any of that. As far as the hardware side goes, I want the students to have mainly this third bullet, Logisim Evolution. I want that installed. If you don't have that installed that first day, we will have to spend some time installing it, which, we can do it, but it'd be better if we have everybody have that installed. So ahead of time, if you sign up for the camp, you can ask me for questions on, hey, how do I install this? This is a jar file. It's a Java application. So you're going to need a Java development kit on it. So I give you the link on where to go to get that if you don't already have it. And then that jar file should be able to launch. And so I want that to be able to be there so that we can kind of hit the ground running in designing circuits in the very beginning of the camp. Tinkercad is a way to generate circuits that you can use to simulate before you actually build them on a breadboard. EDA Playground is a cloud-based Verilog IDE, integrated development environment. I use ModelSim. If you have a Windows machine, you can get it for free, and that is the preferred way to do it. But not everybody has ModelSim or a Mac with Parallels on it, or some boot camp, some sort of boot camp or something in it, where they actually have a Windows virtual machine running. So it's not required that they have ModelSim. So EDA Playground will do it. It's a cloud-based. They have to create an account, and then we can run it with that. That's for the Verilog. That's for the HDL stuff. You must have a personal Gmail account, and they must have authorization available if it's a parent-generated account. I've seen this before, where students will get into their Gmail account, but then they can't access a drive to get a file that they need to read for their data set because their parent hasn't authorized them to access the drive or something like that. So it has to be a Gmail account. It can't be like your school Gmail account, because many schools will firewall off the ability to go outside of their domain. So we need a Gmail account. And then, like I said, if you are setting up security protocols for your kid, right, for the student that's going to be attending the camp, for your son or daughter, then they need to have that authorization available, so that we're not having to call you to authorize the account. Okay, so that's basically what they need then coming in, and that's it. So thanks very much for your time and your patience as I go through this. I can answer questions.
Yeah.
Maybe I've answered some of them.
Hello.
Okay.
Could
Yes,
I ask you a
please.
question? Yes. I see the basic requirement for is math tool. So, but there's still other requests for calculus, linear. So if the student doesn't have this basic, how is it possible for getting a good result?
Yes, I think so. When I teach this at the high school level, many students do not have calculus already. So I will teach them what the calculus functions that they need to know. Okay, so basically what they need to be able to do is a derivative. So if you're familiar with, if you're a math person, you know what calculus is. If you know what a derivative is, that's basically the slope of a function at a point. They need to be able to calculate the slope of a function, right? So some curve at a point. And I teach them how to calculate that slope. That's what a derivative essentially is. We will calculate that, and a little bit further, we will calculate what's called a partial derivative. Partial derivative is what we will use to calculate what's called the gradient in an algorithm called gradient descent. So I will teach them everything they need to know with very focused, view in that concept of calculus. Derivative, partial derivative. That's all they need to know. I will teach them that. So coming in with basic algebra skills, they know how to, they know what a variable is, right? They can solve a complex algebraic equation. They should be fine in, and if they can pick this stuff up, then that'll be fine. They don't need to know calculus coming in. So hopefully that answers your question.
Okay.
Okay, I love it. Thank you.
Yeah, there are more questions. Thank you, Ms. Mauro, for this detailed explanation. So there are some questions coming in. So we start from one by one, maybe it's answered about how it's connected to the real world application. I think you, right? Go ahead.
Yeah, so in general, I mean, I think I tried to connect what my philosophy on being able to expose the students to both hardware and software. That's very real world. Now, in terms of, hey, are you doing some sort of research, project for NVIDIA, for example? Well, no, we're not doing that in the class. However, we will cover the fundamental components that would apply for students to be able to do, apply for internships and research, institutes and things like that. When we are evaluating data sets on the machine learning side, we'll use real world data sets. Many of the data sets we'll pull are from the UC Irvine has a really good machine learning database that we'll pull data sets from. And then I will ask the students to do projects where they'll actually pull data from, their own, they'll find their own data. And those things would be real world type applications where they can generate some trends and make predictions and do projects that they will, hopefully get some meaningful results from that they can use on their on their applications or when they're doing their college apps and things like that.
Okay, good. Okay, so the question with same parents about FPGA in relationship with AI project. I think you explained it, but maybe you can highlight a little bit more.
So yeah, so the FPGAs are, as I mentioned earlier, field programmable gate arrays. They are a hardware platform that's very common for hardware designers to prototype their designs. They allow you to do much more complex designs than if you were to use a breadboard with, wiring basic components together. Those are very, problematic and prone to errors if you, have a wire mismatch. So you do it in an FPGA. I use the company is called Xilinx. I use Xilinx FPGAs. I have an emulation board that I will bring emulation boards to the camp, and students will work with those that we will download designs to, and these designs can be fairly complex. I mean, I had in one of my courses that was much longer than a camp like this. We developed a full CPU, right? A full what's called a RISC-V architecture CPU on the FPGA board. So you can actually implement processors on these And so when we create our designs, we'll put them onto these FPGA development boards. Again, field programmable gate array. It's just a programmable hardware chip that is used for prototyping.
Okay, that's great. Okay, so I'm going down through the chat. I typed in just a little bit of introduction as well. Ms. Mauro and I worked together at Qualcomm for many years. And he taught at CCA, which is the top public school in California. I think there are a lot of CCA's parents and students here. There might be, okay? And in 2019, there are about 12, like at the peak of CCA, 12 students that year, 1 year, got accepted by MIT. It's quite famous, okay? Mr. Mauro also taught both my boys, Asian boys, my boys, okay? And both of them got into UC Berkeley computer science. And so the younger one is pretty much completed with CS, will move to PhD in theoretic math. And the older one actually just arrived today in San Francisco, will start joining the second job in AI in a startup company in San Francisco. So it's a very quick introduction about my working relationship. And Ms. Mauro is our family teacher forever. Once a teacher, forever teacher. Thank you, Ms. Mauro. And Ms. Mauro also wrote a letter of recommendation for both my boys, okay? And then we go down, the students, the requirement is incoming. So I'm gonna make really clear, it's incoming 10th grader. So in the fall 2025, September or August 2025, your student must attend the 10th grade, okay? And so starting from 10th grade, incoming, and can be lower level college students if they're interested as well, that's completely fine. And all students must pass this test, okay? So we don't have, we ask the students on the application form to write some stuff, but the really two very clear criterion is the number of the grade level and the passing the test. No matter how many students, the peak will be 40. And if we don't recruit 40, we will have the camp, no matter how many students I'll be enrolled. I already worked out everything with UC Berkeley, okay? We will have the camp no matter what. So you guys don't have to worry about it, okay? Unless there's some COVID stuff that it's out of anybody's control, okay? So that's where we are, an application form. Okay, so now the next questions, accommodation will be at UC Berkeley campus. Food, dining will be at UC Berkeley dining hall. Okay, so I think some of the parents follow me on the WeChat. The food is not ideal. It's not as enticing as UCLA dining hall. We're working through it. So maybe by the time you get there, your students get there, the dining hall will be much more improved, okay? But for all the working meals during the weekday, yes, 3 meals will be at UC Berkeley. And right now, the dining hall and the residential dorm, it's like 2 minutes away. Okay, so we'll have chaperones to walk with the students, and we have a lunch break, so don't have to worry about it. For commuters, and the parents will pick them up wherever the 5 o'clock or 5:30. And if some students want to stay a little bit longer working through the homework with the rest of the students, no problem. Okay, the commuters, all the lunch will be covered, but for residentials, all meals and including weekend activity. So based on the number of enrolled students, we will have the first cut April 1st, and the price will go up and pretty much finish hopefully by the end of the 1st of May, because we have commitments to UC Berkeley. Everything is planned early, okay, including the bus and the ticket, housing, meals, classroom size, etc. Okay, and we will have, depending on number of students, we will have a bus or minivan, whatever, take the kids around, going to San Francisco, maybe going to Stanford or whatever. Of course, we'll have a tour at UC Berkeley, etc. We'll arrange it. So on the weekdays, during at night, there will be activities. Mainly, I think the kids will be working through the homework, but we will have some other sessions. We'll invite UC Berkeley students to talk about their experience. I will talk a little bit about college counseling. We may invite from the Zoom session to talk about college counseling, what is really important, answer all students' questions, okay? And let me see, go through that. That's residential, just, okay, we will not give out credit. It's not a credit program. I just want to making sure that people say, oh, I want 5 credits, I can transfer into UC Berkeley. No, it's not for credit. It's an extracurricular enhancements, just like you guys attend the ID camp, some other programs. It's not for credit. Okay, just want to making sure we're very honest upfront. I don't want to have any surprises, any disappointment. Okay, and you can list this program. The thing is, listing is really not that important. You guys are learning the best of the best from Mr. Mauro, the best of the best. Okay, I don't think you can find anybody else who has the EECE, CS industry, has many patents, taught high school students, I don't know, 17 years, now teaching at UCSD. Now, I don't think you're going to get any teacher like Ms. Mauro. And this very unique program at combining AI, software, and hardware. You can go find it, anything else, Stanford pre-college, whatever. I don't think anybody has this unique program. So the learning is most important. It's not the certificate, it's not the credit, it's the learning experience. And it will be project-based learning. And Ms. Mauro is the head teacher. Depending on number of students, we will gradually add TAs if needed. I'm at UC Berkeley. I don't work here. I'm a volunteer for UC Berkeley parents groups. Both my kids are here. So we can get very qualified TAs and based on the number of the ratio, okay? But with the dorm, doesn't matter how many students, we'll have a chaperone, male chaperone. It's the 1 to 10 ratio. We only have 20 residential, 1 to 10, 1 for male, 1 for female, okay? So, no, the ratio. So if I have 15 boys, we'll have 2 chaperones at night for boy students, okay? And if I have 5 girls, we only have 1. So we'll have 3 chaperones. You guys got the point, okay? That's required by UCSD. All students have to provide their travel insurance or medical insurance, okay? And we do not, we have liability insurance, but we don't insure your medical incident, etc., okay? And then certificate of completion, yes, Ms. Mauro and us, Haddee Education will provide a certificate of completion. It will be called Machine Learning and AI Foundation. And so I'm just going to be very, very, very honest. The word of AI is a little bit tricky, okay? And it's fine, but it is we're teaching AI, but sometimes, with all this trade war going on between different countries. So I'm not going to talk about politics here right now, okay? Just going to give you a heads up. This is the kind of entire program, Machine Learning and AI Foundation, okay? And what else? Ms. Mauro has a lot of students attended UC Berkeley, and then, okay, so this is the key question, Ms. Mauro, for you. If you have students with different levels, of course, at CCA, I know I've been to your classroom many, many times, and of different levels, and how you handle them, and making sure they're all learning.
Right. So this is where we will have TAs that will help with the different levels of students as we're working through the projects. Normally, the way I do it is that we will work on some lecture material in the class in the beginning of the class, and then the students will be working on projects, assignments also in class. It's not that I lecture the whole time and then they have to go off and do their own work, by themselves. They'll work in the classroom on their projects, and we'll work together on that. So I'll have, I guess, fortunately, I have some experience in working with large classes. I mean, Dan has some knowledge of when I taught her boys. They were both in classes that were probably 35 to 40 students each, and we didn't have actually TAs there. So I have some capability to multitask with students who might be different, with different levels. And so the ones who are, more advanced, we get them working on projects, and, they're working, I push them to get, their projects going, and can help them if they get stuck. And then there's the other students that are struggling. We have TAs that will help them, and then I'll be able to help them as well. So we'll, like I said, we'll have focused time where the lecture material is presented to the students. We will have reference material, videos, things like that, where the students can replay and look at the reference material again if it's something that they need to get more background on. and then we'll help them with their projects in the classroom. So we'll have that. I think I'm confident that, you know, unless we have 100 students in our camp, which would be great, but we'll have many TAs. You know, as Dan said, as we get more and more students, we'll get more and more TAs that will be very qualified to help students as we kind of move up. And so I'm pretty decent at being able to manage students in the different levels, just from my own experience.
So yeah, for this camp, the cap is 40. Me and Ms. Mauro agreed. 20 residential, 20 commuter. That's it. Okay.
Yeah.
And so just want to let you know where the classroom is. The classroom and the dining, the dorms are right next to each other. That's why we chose, because there's a lunch break. After lunch, the kids can go either work in the classroom or go back to dorm or take a nap. So we would very, very, very secure area. Maybe UC Berkeley campus is gigantic and walk. You know, I don't want the kids to get lost. So we'll have some group tours and we walk around the campus, have some fun. I'm going to have UC Berkeley students, during the weekends or even during the week, because it's really nice here at UC Berkeley during the summer. It's a little bit quiet, but the daylight is very long. It's northern, so it doesn't get dark until 9 o'clock. And so, we can have some organized group tours walking around. But that classroom UC Berkeley assigned to us is right next to the dorm. You can go out, go to the courtyard, and you will access to the classroom. It's a very, very big classroom. So we're going to have the classroom set up as a project based, but we also probably will put a pool table or something. So at night, if the kids get bored and they have some activities going on. So we're making sure the kids have great experience. I'm experienced in doing summer camp. We used to have one in at UCSD. Everybody loved it. Okay, and Mr. Mauro and I also held commuter program at CCA right after COVID. Okay, all went very, very well. Okay, so here, Mr. Mauro, you want to answer the question? Did we answer about linear algebra, calculus, and stats? Or that's already answered. Is that required?
Well, yeah. I think the gentleman asked about what was the requirements for it. So I will teach them everything they need to know for machine learning as it relates to statistics and the linear algebra and calculus. So if they know these basic concepts already, then it'll be a review to them. But if they don't, then as long as they've had second year algebra, I think they will be able to take this stuff up pretty quickly.
Okay. So Mr. Mauro knows what he's doing, and you don't have to load it up with linear algebra, calculus, and stats before the camp. He will teach your students some very, very necessary skills for your student to move on and for those areas. Okay, I think that's very clear. And okay, so Mr. Mauro, if you have students with, we already answered that, different levels, we talk about student TA ratio. And this is a good question. Does each student have their own project or work to showcase at the end of the camp?
Yeah, that's actually a really good idea. What we have, because it's only a 2-week camp, I try to push them through kind of very structured program. At the very end, where we talk about the capstone, if you saw in my my day-by-day kind of schedule, at the very end there's a capstone project, right? So at that time, if the student is very keen on doing their own project, right? They say, hey, I'd really like to implement, this or that algorithm. Then I'm open to it. I've done many courses where I've had final projects that the students can do their own thing. The challenge with it is with students is that they tend to overestimate what they can get done in a certain amount in a small amount of time, right? Because we have lots to cover, and if we have 2 or 3 days, to complete a standalone project, I would have to work very closely with the student. If they know all this material coming in and they say, all I really want to do is work on a project, okay, I can work with them on this. But with a 2-week camp, it's going to be very difficult for them to conceptualize, implement, and test and demonstrate a full-blown project on their own. So we can definitely consider it. We'll see how things go as time goes by. If the students are in this camp are very advanced and we can get through all the material very quickly, then for sure I would love to do individual projects that they do at the end. But I think what we're going to end up doing is a capstone project that will be basically like a neural processing unit on the hardware side. And then on the machine learning side, it'll be some application of a deep neural network. I'm flexible with that. If it turns out that the students want to do something that's more tailored to their own project, they can do that. That said, too, I work with many students after summer camps like this to work on standalone projects. And I think even Dan had published a couple students that I've worked with in the past that published papers towards data science and other in the San Diego greater San Diego camps that they've done that have published papers with research projects. So I actually work with students who are very motivated and the best students I usually will work with them one-on-one on if they want to do some different projects that they can use for their college app. So I'm very interested in working with students as well, even after the camp.
Yeah, one of the students that was very early with our machine learning program, I think got into a bunch of school, decided to choose Harvard, and we shared some of the information there. Yeah, so that's actually pretty good to address the question some parents are asking after the camp, what will be continue? That will be individual cases because your kid's going to be really, really, really busy as well with the schoolwork. So I don't want to set up like, we're going to get you this published, Ms. Mauro going to work with you on this and that. That's going to be individual based. Okay, so we can talk about after the camp. We love to work with the kids, but sometimes they're simply too busy. I don't want the kids to be overloaded. Okay. Yeah, so that's definitely a possibility. And for some kids very advanced who are coming in, and Ms. Mauro already said, individual project as well, based on the same concept approach, individual projects, it's also a possibility. Okay. So
yeah, I want to make sure that sorry, Dan. I just want to make sure that everybody understands that if they think that their son or daughter that comes into the camp already understands all this material, first off, almost always the student will learn something. They usually don't know as much as what they think they know in terms of what we're going to cover. That's my own experience with students. They tend to overestimate what their knowledge base is. But if we do find kids that come in and they're really getting through this stuff very quickly, I'm very open to working with them on individual, if they have some, new thing that they're looking at, and it's along the lines of what we're covering with the camp, then I'm very willing to work with them on it if they want to kind of work through a project. As Dan said, I'm highly skeptical that we'll find many students that will be that advanced that they'll have this knowledge base, especially the hardware and software combination. But if there is some, I'm open to working with them. I like to do advanced things in myself too.
Great. Yeah. So, and also if the students do really well and talk really well and really have a lot of initiatives, are willing to help students, will observe. And next year, the same camp, similar camp, and the student can be qualified for TA, okay, as volunteering. And the TA is a very, very, very good extracurricular or in-classroom activity. And my older son did a lot of TA for Java, and actually I think both my kids did TA for Mr. Mauro in SCCA. Okay, so TA is really good, but we don't want to promise to anybody until until we know the performance, and it's not going to be me choosing. Okay, so don't call me. Miss Mauro will be choosing students who are interested in TA, and then we'll talk about it for commuter. TA is a little bit easier, but for residential, you know, who's going to cover the housing, and I think, you know, it will be hard for us to cover the housing. So if the parents want to house the kid for TA, but that's next year. I don't want to go, you know, jump to the next year. So, but that's the plan. Okay, that's the plan. And if none of the students, existing students, are interested in being TA, no problem. We'll have UC Berkeley students, and you know, many of them will be very interested in being a TA to Miss Mauro. So that's not an issue. Okay. So, and what else? We talk about it. Oh, AP Computer Science, and with AP Computer Science A and Calculus AB will be a good fit for the program, Mr. Mauro.
Yeah, if they've had both those courses, they are they're definitely prepared on the math side, and they'll understand object-oriented programming, so they'll be fine there. You know, like I said in the beginning, we cover pretty much all of the foundational components of Python, including object-oriented programming. So even if they've had AP Computer Science A, that's Java-based. So if they know Python, great. If they don't know Python, then at least they'll understand object-oriented programming, which is needed for both the hardware and the software, especially when we get into the Verilog part of the hardware side. So yeah, it's definitely a good fit for somebody there. I don't think that they're overqualified because they've had calculus and APA. But they will be in good shape, at least for the first couple days.
Very good. Okay, so Ms. Mauro, you teach at UCSD, you have some online courses. What is really your online courses? What's the difference between the summer camp?
This is taking my online courses that I have 3 of them that I teach at UCSD, 1 per quarter. So it's effectively a full year worth of, you know, UCSD courses, and I am picking pieces of each one of those courses and then condensing it into 2 weeks. So you're going to see, you're not going to get everything that I teach in UCSD, obviously, but you're going to get a good kind of review of what is taught at, you know, a much greater deep dive at UCSD. Same basic topics.
Yeah, plus kids will work together and use the hardware.
Yeah.
Right? That's
yeah, so that's right. Yeah, the courses I teach at UCSD aren't combined like this. This is pretty new. The things that I do at UCSD, I have a series in machine learning, that's the software side, and I have a different series in circuit design that's completely separate. So the students aren't necessarily, there's some students that do both, but they don't combine. This one we are combining both. This is new. This is something that I think are going, you know, it's kind of like the EECS program at Berkeley, right? The combination EECS program. It's kind of like that, what we're doing it in a summer camp, right, for high schoolers. So I think it's pretty unique. I think Dan, I don't think I know of you mentioned this, right? I don't know that anyone's doing stuff like this.
Yeah, I don't think so. We have a database of 3,000 summer programs, and I search, and really nothing like this come up. Okay, that's what I said. I can't guarantee this is the only one, but I think I'm pretty sure it's pretty unique with a combination of AI. Right now, AI is really, really hot, especially with the robotics coming in, and a lot of kids have robotics experience. I think the combination of the hardware and the software is really good. For past decade or 20 years, software engineers were making loads of money, but right now the things have changed. So if your students are equipped with both hardware and the software engineers, because robotics is really coming up, and if any of you tried the Tesla, FSD, you will know that's a real hardware and the software application, real world for AI. Okay, yeah. So and camp best suited, yes, for high school students, we talk about incoming 10th grade. However, if you have an incoming 9th grader, if you think your student is genius, really knows what stuff can pass the test, Mr. Mauro will have to individually interview your student, because we are looking for maturity, and we do not want to have your students feel out of the place if there's no maturity. So if you insist that my student can do it, your student's very psyched about it, no problem. We'll arrange an interview as an exception. But for passing the test and the grade, it's pretty much the bare minimum. Okay, so completely merit-based. Okay, and incoming 10. So right now, if your students enrolled in 9th grade, no problem. Okay. And okay, so here's a question: is it possible for kids to finish a project by themselves, such as a computer vision program or NLP after the camp? I think we talked about it, right, Mr. Mauro?
What was the question about NLP?
Something? Yeah.
Possible kids to finish a project by themselves, such as a program vision pro. Definitely after the camp. Actually, it's interesting you mentioned NLP. So I'm actually working on an NLP series for UCSD right now. It's a 3-course series in natural language processing. So I'm pretty familiar with that area. And but yeah, I mean, if you're, we're not planning on covering, we don't have the time to cover NLP in this camp. This is more of an introductory stuff. You have to, the stuff that I'm doing at UCSD, NLP will require that you have had the 3-course machine learning series before you actually enter the NLP series. So it requires that you have some knowledge base of that. And so for the student who wants to do some, computer vision or NLP after the camp, for sure, they will be prepared for it. And that's what I do for the students that I have at UCSD. I prepare them for NLP with the machine learning series that I have, that as I mentioned earlier, I'm kind of condensing into this 2-week, sort of crash course in machine learning and in hardware side. But they could do NLP after this camp if they get through that.
So then the next questions. Yeah, we'll share the recording. What is the camp date? Okay, we are already shared, but we're going to share again the dates. First, I'll tell you the YouTube channel will be uploaded there. It's also on our website, maybe tomorrow, hopefully. And the dates is, okay, here, write down. July 20th to August 1st, 2 weeks. Kids will check in on Sunday. You cannot check in on Saturday. Sunday accommodation will be provided, and we'll leave on Saturday. Okay, so please write down. I don't know if the 20th is Monday or Sunday. Let me take a look at it. Okay.
21st is Monday.
Yeah. So you checking the commuters is coming in on the 21st, but for commuters and in the morning. But you checking all students, international students, whatever, the out-of-state students. Residential students checking on Sunday. We'll have a check-in booth and dinner will be provided. Okay, we'll have some orientation, have some fun. Okay, regarding the cost, I share the link here. It's on our website, copy and paste. And we have a multiple cost. We have US residential, early bird, regular, US commuter, early bird, residential. We have international student. Price is completely a little bit different. And it's very, very common for UC Berkeley programs to charge international a little bit of premium. And as a matter of fact, you guys know tuition, it's all different here. Okay, so I don't want to go into detail, justify it. We vet it out. It's very fair. All price will go up April 1st. Anybody sign up before that? Because the later we commit to UC Berkeley for all this logistics, the higher the cost is. So fair. Okay, and we also have international commuter. Some parents are bringing 2 kids and they want to rent a hotel. Fine. Okay, maybe they have the housing during the summer arranged. No problem at all. And if you open it up, all cost is on our website. You look at the introduction and going down to the bottom of it. Okay, there are many, many prices. So I'm not going to here and talking about the price here. It's all published and very, very transparent. And if you want a syllabus, I'll give you the syllabus. Ms. Mauro just presented, okay? Here you go. And here's the syllabus, okay? All the requirements, everything, whatever need to be installed, it's all there. All enrolled students will receive orientation training with Ms. Mauro, will help you guys, install. And if needed, one-on-one support. We'll all support making sure when you come to the camp, you're all equipped. There's no surprise, and we'll get to work. And you can see there's a lot of work. Okay, it's very challenging. However, it's rewarding as well. Okay, and okay, so we talk about the cost. Okay, Dylan. So I'm not going to repeat here. What are some examples of projects included in the camp, Mr. Mauro?
So we do what's called on the machine learning side, we do what's called exploratory data analysis. This is like data. If you were a data analyst or a data science engineer, then you will take data sets and you analyze them for trends, and you look at different statistics in the data sets. So we'll look at that with real world data sets. So we'll be able to pull from, like I was mentioning earlier, we pull from the university databases at Irvine and others that have these types of data sets available. As far as the other projects go, we have on the hardware side, we do the base components of a processing unit, like a arithmetic, what they call an ALU, arithmetic logic unit. We'll look at the basic structures that are used in a neural processing unit. You will implement in the software side, a deep neural network, and we'll use that to classify different types of data. So we'll do, very basic functions that are binary in nature. So we'll use, binary classifiers, but then we'll expand those out into classifying images, and things like digits and things like that. So there's different applications of each of the algorithms themselves. At the very end, the capstone project will be to implement a fully functional neural processing unit, and so we'll take advantage of what we know in deep neural networks to know what essentially a multi-layer perceptron model looks like with weights and biases, and then we'll implement that in hardware so that we can accelerate it. And so that is a kind of a generic neural processing unit.
Okay. Yeah, so I think you repeat the question already being answered is Dylan wrote a bunch of things that what you will learn, and okay, with those knowledge of these topics, you'd be willing to work more intimately to explore more advanced concepts. That means that the student coming in with everything knowing, and then did you see that question from Dylan?
Yeah. So, like I was saying earlier, if the student comes in and has a knowledge base of all of these, the concepts that we're covering already, then yeah, I mean, I'm happy to work with students to explore more advanced concepts. Again, what I've seen in the past is that a lot of times, even though students will know, maybe one area very well, maybe they don't, they know how to call a model, a library API, and know how to, configure a neural network very, very quickly. But do they understand the very details of how the training is done? Okay, so that's one area where I would be, wanting to know, does this advanced student know these concepts already? So that's one area. Do they know both the hardware and the software concepts? If they maybe are really good with software, but they don't understand the hardware, they're going to spend some time with the hardware piece of this camp. So before I say, yeah, let's just do, a standalone research project for the quote advanced student, I would want to evaluate them and say, okay, well, what exactly do you know, and how advanced are you? And if they are there, then for sure, yes, I would do that. But I would want to evaluate that first.
Okay, okay, that's great. Okay, and then, yes, so we talk about the camp days. We will not hold a second camp in San Diego. The only camp this year will be at end of July, July 20th to August 1st at UC Berkeley. And Miss Mauro is, and I are both in Berkeley. So next year, whether we do it in San Diego or, UCLA, we'll discuss that. But this year, only one camp, okay? I make it really clear. And so we have, as Haddee Education, we provide a lot of college counseling. So if the kids are interested in college counseling, can connect with us. We provide all the standard process. That's our email for any questions, WeChat. And we have a team to support you, WhatsApp, whatever, okay? If you like it, you can give us a really good review for this session. If you think it's useful, that will be very helpful. And any other questions we have here? Are we all pretty much exhausted all the questions? Mr. Mauro?
I think so. I don't see anyone's in the chat that we haven't already looked at.
Okay. So we have a very standard process. I send it twice. 2 forms we must receive from your students. Application form, the price you can go take a look at it on the website. Okay, that's completely fine. It's all public. 2, one is your student's test and your student's application form. Your student's application form need to have the parent's email and the parent's full name. So we'll look at your test, see whether you pass, and 80% up, we'll see, and we'll tell you. We're pretty fast, 24-hour turning around. We'll email you and the students, hey, congratulations, you passed. And if we already have an application form, we will send a standard DocuSign to the parent. Everything's automatic. Parents sign and pay, and through Zeller or whatever, and then you'll be enrolled. Okay, so and the deadline to enroll with the current price is April 1st. I'm sorry to say April 1st. It is April 1st. The reason we put down, I know many of you are applying for ISI, maybe MIT. The result already came out. Okay, maybe some other camps like Cosmos and stuff. We accommodate you guys. I think our camp is much cooler and learn many more things, but I'm not going to convince you guys. So you already have the application go through, and I think many of you will hear about from those summer programs in March. So I think setting April 1st date is very fair. And plus, I think our camp is much more productive, but no, I said enough, right? So, okay, any other questions from parents and students? Your last chance. Okay, yeah, please feel to connect it to us. You can join us as we have WhatsApp, we have WeChat groups, we have newsletter. You can receive information. If your kids don't want to join this year, no problem next year. And but at least you will be informed about what's going on. Besides that, we have college counseling, tutoring, SAT prep. We have research with a professor. Last time, Ms. Mauro is also here with a bunch of professor. We have MIT professor from Duke, AI one-on-one research. We have really cool programs. So I am very, very grateful that we are working with teachers, experienced teachers like Ms. Mauro. So thank you, Mr. Mauro. Thank you for your time. All good. Okay. Yeah.
Take care, everybody. Thanks for coming.
Thank you, Ms. Mauro. So we'll talk to you guys soon, okay? And we'll send the recording. Have a great night, okay? Bye-bye.
Bye.
Bye.